Students, and welcome back. We're going to be working on our last lesson for the year, and this is on solving radical equations. These are going to be equations that have square roots in them, and I have an example of what we're going to need to do. The first would be that you want the square root to be the only expression on one side of the equal sign, like we have here. So the square root of x, and then equals some other expression, in this case 10. To remove the square root, we're going to raise each side to the second power. So I put the square root inside of a parentheses, raise it to the second power. Do that to each side of the equation. Squaring will undo the process of doing a square root. So the square root will go away. We'll just have x equals, and then 10 to the second power in this problem is what we get, which is 100. And so x equals 100. You do need to check your answers for what we call extraneous solutions or roots. And that means answers that you get that might not check in the original problem. So be aware that you do need to check your answers. So we'll take a look at our first equation, in which the square root is all by itself on one side of the equal sign. So our first step will be to raise each side of the equation to the second power. So I'm going to show that in this step number 1, raising each side of the equal sign to the second power. So you'll see that the only thing not in the parentheses is the equal sign. All right, so squaring undoes a square root, and so the square root goes away, but the inside stays. So 7r plus 2 equals, and then we need to do 4 times 4, 16. Now you have an equation that you need to solve. We will subtract 2 from each side of the equal sign, and that will give us 7r equals, and then 16 minus 2, which would be 14, and then divide both sides of the equation by 7. Again, we're solving an equation here so that r equals 2. Now, you could use Desmos or some other method, but actually I think I'll go ahead and show Desmos. Plugging your answer into the original problem in place of the variable. So you'll want to bring up the square root symbol. Whoops. Let me close this, move it out of the way. So bring up your square root symbol. Do 7, and it was an r where we got a 2. So it's 7r plus 2 inside of the square root. We got an answer of 2. And as you're doing the check, you want to make sure that you make it look like that original problem. And that does give us 4. So the answer checks. It said that 7r plus 2 was supposed to equal 4 when it was inside that square root. Okay, so our second problem is where we have the square root not by itself. So we're going to have to take a first step and get the square root by itself. So I'm going to need to subtract 1 from both sides, make that look more like a subtract sign. So this will give me the square root of 10h. The ones are now gone, equals, and then 21 minus 1, which is 20. Now the square root is the only thing on the left side of the equal sign. So we're going to raise each side to the second power. And that will make the square root go away. So we'll have 10h equals, and then 20 times 20, which is 400. And then to solve for h, we just need to divide by 10 on both sides of the equal sign, and we get h equals, and then that'll give us 40. So once again, you can use Desmos to check. So we would want to have the square root of 10 times 10 inside of a square root, and then plus 1, and that should give us 21. So let's check that out. If we do the square root of 10 times 10, since that's the answer we got, and then plus 1, it wasn't 10. Sorry about that. It was 40. So the square root of 10 times 40, and then plus 1, and that should give us 21. And it does. So that answer checks. Another thing we're going to do is put your answers in a solution set. So at the end of the problem, go ahead and put your answers in a solution set. And that'll let you know that they do check. All right, on your third problem, you have a square root of 3x minus 6, and then your equal sign, and then another square root of 2x plus 1. And so we have the square roots by themselves on the side of one side of the equal sign. It actually happens on both. So you can square both sides, and this makes the square root go away. So we'll have 3x minus 6 equals, and then on this one, 2x plus 1. So on this, we'll need to get the x's on the left. We're going to minus 2x from both sides of the equal sign. So 3x minus 2x, which would be x, minus 6, which would equal 1. And then we would need to add 6. We want to do that to both sides of the equal sign. And that gives us x, because this is going to be gone, equals 7. All right, again, we can check this. In this square root, we want 3 times 7 minus 6. So let's check out what that is. So the square root of 3 times 7 minus 6. And it does give us a decimal, but the other side is also a square root. And it's supposed to equal the square root of the 2 times the 7 plus 1. So I'm going to get a new calculation area here and do the square root of 2 times 7 and then plus 1. And if I move this out of the way, we get the exact same decimal, so we do get a check. Our answer does work, so we want to put that in a solution set. So the answer turns out to be 7. All right, if you'll turn your papers over, we've got another problem with the square root of 2x plus 3 equaling x. So we've got the square root by itself. We're going to raise each side to the second power. And so on this side, the square root raised to the second power goes away. So you just have 2x plus 3. And then you have equals x squared. So when we have this situation, when you have a square, you have to get the equation equal to 0 so that you can find your a, b, and c. I like to keep the x squared positive, so I'm going to subtract 2x, and I'm going to subtract 3, so that 2x minus 2x is 0, 3 minus 3 is 0. One side of my equation equals 0. And then over here, I'll have my x squared first, minus the 2x, minus the 3. So my a is 1, b is -2, and c is -3. And you have two options. You can solve by factoring or by the quadratic formula. Since we did factoring the other day, I'm going to continue to use that. So we would look to see what would multiply to give us the AC. 1 times -3 is -3. What would add so that it would give us B, which is -2. So numbers that multiply to 3 would be 1 and 3. If we make the 3 negative, then we'll have the right signs when we add them up. So 1 plus -3 will give us -2, and 1 times -3 will give us -3. So we take the x squared, and then we use our numbers that we found for the middle. So plus 1x minus 3x, and then minus 3 equals 0. We'll do a cut line. We can divide both of these by x. So dividing by x, then we get inside the parentheses x plus 1. On the next part, we can divide by -3. So we'll bring down the -3, and that's going to give us x plus 1. Then remember the equals 0. So our matching parentheses, x plus 1, and our other parentheses, x minus 3, and then equals 0. And now we set each parentheses equal to 0. So the x plus 1 equals 0, and the x minus 3 equals 0. We can subtract 1 to both sides and get x equals -1. We can add 3 to both sides and get x equals 3. Now we have two answers. One answer we need to be a little suspicious of because it's a negative, and often we have an issue with square roots if they equal a negative. So I'm going to check the -1 using Desmos. I want to put it in the original problem. 2 times -1 plus 3 inside the square root. So inside the square root, 2 times -1 plus 3. And this says that the answer is 1, but on our paper, it says that it equals the x, which is -1. So 1 does not equal the x, the negative 1. And so this answer, x equals negative 1, does not check. So the square root of 2 times the negative 1, I wanted to write that in red. And then plus 3, that does not equal the negative 1. And so that answer does not check. Now, we should also check the 3. So I'm going to put the 3 in the original problem. So 2 times 3 plus 3 inside of a square root. So I'm going to change this to a 3, and we should get that answer we started with, which we do. So that answer does check, and that would be our solution. So the 3 is our solution set. And then finally, we have one that's a little more difficult. We have this square root of m plus 59 equals m plus 3. So we have the square root by itself. I'm going to rewrite it. And then we are going to raise each side to the second power. And so on this side, the square root is going to go away. We'll have m plus 59 equals, but on this side, notice that I didn't square individual terms. I squared sides. So that means I'm taking m plus 3 times itself, which I'm going to go ahead and write twice. And we're going to do the process of multiplying it out. So the left side, I'm just going to keep recopying. And then this side, we would take m times m. That's going to give us m to the second. We would take m times 3. That's positive 3m. Then we'll multiply 3 times m and 3 times 3. So that we take m times both of these and 3 times both of these. All right, so that's m plus 59 equals, and then on this side, we'll have m to the second. These two are going to combine to give us 6m and then plus 9. All right, so, since we have a square term in here, we're going to need to, like the last one, get it equal to 0. So we're going to need to minus m to both sides. We're going to need to minus 59 to both sides. Notice that they have like terms that I am lining them up with. So I'm going to get 0 equals, and then m squared plus 5m minus 50. And then we're going to do the factoring. So A is 1, B is 5, C is negative 50. So we look for what multiplies to AC, which is negative 50, and what adds to give us B, which is 5. All right, so for 50, we have 1 and 50. We have 2 and 25. We have 5 and 10. If we make our 5 negative and our 10 positive, then we can get our positive 5 that we need it to add to. So we're going to start with m to the second, then our two numbers, minus 5m plus 10m, and then minus the 50 equals 0. All right, so cut line, we can divide by m, and that's m times, in parentheses, m minus 5. We can divide by 10. It is a positive. And we get the matching parentheses, m minus 5. And then we have the equal 0. So we get our two parentheses, m minus 5 and m plus 10. And we'll set each parentheses equal to 0. So starting with m minus 5, letting that equal 0, and then m plus 10, and letting that equal 0. All right, so we would need to add 5 to both sides. That gives us m equals 5. Here we'll need to minus 10 to both sides. And that'll give us m equals negative 10. All right, so we need to check. We need to check the 5 first of all, putting it in this square root and then putting it over here. So we'll use 2 Desmos. First one is that it was m, which was 5 plus 59. So inside the square root, we got 8. And then we're supposed to check if that equals, on the other side, the 5 plus the 3. So 5 plus 3. And so we got the same answer on both. Okay, so the 5 checks. Let's check the negative 10. So plugging in negative 10 plus 59, that square root gives us 7. And then we need to do negative 10 plus 3. That gives us negative 7. These two are not the same. And so the negative 10 does not check. So I'll show that here on the paper. When we plug in the negative 10 plus the 59 inside the square root, that does not equal when we plug in the negative 10 plus the 3. Because this gives us 7, and this side gives us negative 7. So 5 is our only one that checks. All right, so there's your solution, and those are your examples for today's assignment, which is an Alex assignment. Good luck with your homework.